For this project, we attempted to create an airbag that, when attached to a cart and block, would minimize the force of a collision between the block and a force plate and prevent the box, modeling a person in the car, from falling over.
Oh boy, sure would be a shame if we got into an accident.
That would be bad.
Well, good thing we have an airbag with us.
That was a bad crash. It's a good thing we had our airbag to slow our force down.
For our first prototype, we attempted to create an airbag that was filled with cotton stuffing to soften the impact and had a metal wire framing on the front that would serve as a crumple zone.
We predicted that the collision would cause the metal frame to crumple, slowing the cart down. Then, the cotton stuffed bag would further slow and minimize the force of the impact.
During the testing of the prototype, we used a force plate, laptop with Logger Pro, ramp, cart, block, tape, fabric, cotton stuffing, and metal wiring. Our procedure for testing was to tie the airbag to the cart, start the Logger Pro recording, and release the cart, letting it roll down the ramp and hit the force plate.
This is the force time graph that the force plate gives you for trial 1 with prototype 1.
For our second prototype, we created an airbag that was a balloon wrapped in a pillow so that the pillow would soften the initial impact and the balloon would compress, slowing the cart down so that the block wouldn't fall.
We predicted that the pillow would lessen the force of the original impact and keep the system from bouncing backwards, while the balloon would compress, further decreasing the force and preventing the block from tipping.
During the testing of prototype 2, we used a force plate, laptop with Logger Pro, ramp, cart, block, tape, fabric, cotton stuffing, and a balloon. The procedure was the same as for prototype 1.
This is the force time graph given by the force plate for prototype 2.
For this procedure, the dependent variable would be the force, and the independent variable would be time, as seen on our graph. Since we're trying to find the force, it's going to be vital to find the mass of the cart, which is 0.2346 kilograms, the block, which is 0.0942, the collective mass of the cart and the block, which is 0.3288 kilograms, the mass of the cart, the block, and the first prototype for the airbag, which is 0.3588 kilograms, and lastly, the mass of the cart, the block, and the second prototype, which is 0.3613 kilograms.
Wow, I guess that was a real tour de force for our airbag.
Now, as for our reflection, all of the physical requirements of both prototypes were met by the group members. The functional requirements for prototype 1 were not met, but prototype 2 was successful in function and did not tip the block that was acting as a person. Some issues encountered while building were the restriction of 15 centimeters off the second prototype as we were using a balloon. We had to take some air out of it. Another issue we encountered was with the first prototype not working at all. It completely jostled the block forward and was not deemed functionable. While we wanted to make the prototype collapsible, the first one did not work at all. We realized we needed way more cushion, which is where the balloon came in. When just a balloon didn't work, we added some of the stuffing from the first prototype to it, and only then was it successful. One improvement we can make in the future is finding something more durable than a balloon, because balloons deflate over time and are vulnerable to sharp objects.